Imagine you wake up tomorrow and every weather app on Earth stops working. Not just your phone, all of them. Every satellite, every radar station, every meteorologist, gone. And it's October, and you live in the mountains. And your entire family is depending on you to figure out if a blizzard is coming before it buries you all alive. What do? You'd probably panic. And honestly, you deserve to, because without technology, predicting weather isn't just hard, it's nearly impossible. Unless, of course, you know the secret language that nature has been screaming at us for thousands of years. A language that ancient humans not only learned to read, but mastered so completely that they could predict catastrophic storms weeks before they arrived. With no phones, no science degrees, and definitely no weather app with a cute little snowflake icon. And here's the wildest part. Some of what they figured out, modern meteorologists still use today. We just dressed it up in math and forgot where it came from. So how did they do it? And what are we missing? Let's go back, way back, not to a classroom, to a freezing cold hillside, roughly 20,000 years ago, where a small group of humans is about to face one of the most terrifying challenges our species has ever dealt with. You're not the smartest person in your tribe. That title goes to an older woman, let's call her Aya, who everyone watches like she's carrying the secret to survival in her skull. Because she basically is. There are no books, no libraries, no Google. Just Aya, her lifetime of observation, and the natural world outside the cave entrance. And right now, Aya is staring at a caterpillar, which sounds ridiculous, until you understand what she's actually doing. The woolly bear caterpillar has a brown band in the middle and black bands on each end, and for centuries, people noticed something strange. When the brown band is wide, winters tend to be mild. When it's narrow and the black bands dominate, brutal cold is coming. Now, modern scientists have debated this forever, and the results are mixed, but here's what actually matters. Aya wasn't relying on just the caterpillar. She was running a mental checklist that would make your smartest friend feel humble. Because this wasn't guesswork, this was pattern recognition built on thousands of years of accumulated human memory, passed from generation to generation through stories and ritual and daily observation. It was, in a very real sense, the world's first database. But wait. Here's the part nobody talks about. Reading nature's signs wasn't just a cute hobby for ancient people, it was survival arithmetic. Get it wrong and you don't make it to spring. We're talking about entire tribes that went extinct not because they were weak or stupid, but because they misread the signs. Because they left for the winter valley 1 week too late. Because they didn't stockpile enough food. Because they trusted the wrong signal. The stakes were not inconvenient commute in the snow. The stakes were everyone you love dead. So what were the signs they were actually reading? Let's start with the sky, because this is where it gets genuinely mind-blowing. Ancient humans had something we've almost entirely lost: dark skies. No light pollution. Every single night, the heavens above them were a blazing, detailed map of time. And they learned to read it like we read a clock, because for them, it literally was a clock. The position of certain star clusters told them exactly what season was approaching. Indigenous peoples across 6 continents independently developed astronomical calendars to track when cold weather would arrive. The Pleiades star cluster, a little fuzzy smudge you might have seen on a clear night, was used by cultures from Australia to the Americas to time the arrival of cold seasons. When it appeared at a certain angle at sunrise, you had roughly 6 weeks. Start preparing. Think about that. A smudge of stars, 6 weeks of warning, more lead time than your local news channel gives you on a Tuesday. But the stars were just one layer of the system. And this is where things get even stranger. Animals. Ancient humans paid obsessive, almost embarrassing attention to animals, and not in a cute nature documentary way. They were watching for extremely specific behavioral changes that signaled atmospheric pressure shifts, changes in the environment that animals can feel days, sometimes weeks, before any human can. Here's your counterintuitive fact for the next 2 minutes. Animals are better barometers than most instruments built before the 20th century. Birds fly lower before a storm because dropping air pressure makes high altitude uncomfortable. Geese migrate earlier when a brutal winter is coming. They feel the shift in pressure before any snowflake forms. Cows, famously, lie down before rain. Sharks dive deeper before hurricanes. Frogs get louder before wet weather because they're amphibians and they thrive in moisture. And ants? Oh, ants are incredible. Certain species of ants build taller, steeper mounds before bad weather, essentially constructing little architectural shelters against the coming cold. Ancient people noticed this. They watched ant colonies the way we watch the evening news. Now, you might be thinking, okay, but how accurate was all of this really? Were these people actually predicting weather, or were they just getting lucky? And that is an excellent question. And the answer is going to make you feel slightly embarrassed about your reliance on your phone. Studies of indigenous weather prediction systems, particularly from communities in the Pacific Islands, the Andes, and sub-Saharan Africa, have found accuracy rates that rival short-term modern forecasting, not long-range satellite modeling, but 2 to 5 day forecasts dead even. And for medium-range seasonal prediction, traditional systems sometimes outperform modern tools because they incorporate local microclimate knowledge that no satellite can capture. The mountain valley where your tribe has lived for 400 years behaves in ways that a weather model covering 500 square miles simply cannot account for. But here's what's really wild, and I mean truly, sit with this for a second wild. The most sophisticated ancient weather prediction systems weren't just observational, they were interconnected. Aya wasn't just watching one sign, she was cross-referencing dozens simultaneously. Thick onion skins in autumn. Old European farming wisdom meant a hard winter coming because plants were supposedly responding to something in the soil and air. Unusual spider web patterns. The height at which wasps built their nests. How furry the deer looked in early fall. The behavior of fish near the water's surface. How early the leaves were falling. How loudly the crickets were chirping, and yes, crickets actually have a mathematical relationship between their chirp rate and temperature called Dolbear's law, which was formally described in 1897, but which people had been using informally for millennia. Each of these signals was a single data point. Alone, they're unreliable. But when you triangulate 15 of them and you have 4 generations of context for how they interact in your specific location, you have something astonishingly powerful. It's basically machine learning. Except the machine is a human brain shaped by 10,000 years of necessity. Now, here's what modern people get catastrophically wrong about all of this. We tend to look at ancient weather prediction and think cute, primitive, superstition dressed up as science. And that dismissiveness has actually cost us. Because when colonial powers disrupted indigenous communities around the world, they didn't just erase cultures, they erased knowledge systems. They erased databases of local environmental intelligence that took centuries to build and cannot simply be reconstructed. Right now, climate scientists are in a race to document traditional ecological knowledge before the last people who carry it are gone, because that knowledge fills gaps that satellites and sensors literally cannot. Indigenous communities in the Arctic documented changes in sea ice behavior decades before scientific instruments caught up. Aboriginal Australians had seasonal calendars based on ecological indicators, flowering plants, insect emergence, animal behavior that are now being integrated into formal land management and weather systems. We threw away the manual, and now we're trying to rewrite it from scratch. But wait, because this wasn't even the biggest problem ancient humans faced. The hardest part of all of this wasn't reading the signs, it was trusting them when everything in your body was screaming otherwise. Picture this. It's a warm, almost pleasant autumn day. The sky is blue, there's a mild breeze. Your tribe is comfortable, food is good, and Aya walks in and says, "We need to leave, now. 3 weeks of travel ahead of us, pack everything. The hard winter is coming and we need to reach the valley before the first major snow." And everyone looks at the blue sky, and someone, there's always someone, says, "Are you sure? It's beautiful out." That is the exact moment where civilizations were won and lost. The willingness to trust accumulated wisdom over immediate sensory experience, to listen to the ants and the stars and the caterpillars even when your eyes were telling you a different story. The ancient weather reader was not just a scientist, they were a leader, a communicator, a storyteller who could make the entire tribe feel the urgency of invisible danger. That skill, translating pattern into action before the crisis arrives, is arguably the most important cognitive leap in human history. And here is the big lesson, the one that actually matters today. We live in an age of unprecedented data. We have more weather information available to us in this moment than any humans who ever lived. And yet, we are profoundly bad at responding to slow-moving environmental warnings. We see the data, we acknowledge the trend, and then we wait, because today is nice and the problem feels abstract. Ancient humans didn't have that luxury. The consequences of ignoring the signs were immediate and lethal. So they built cultures, rituals, and stories specifically designed to make the future feel as real as the present. The woolly bear caterpillar wasn't just a caterpillar, it was a story, a reminder, a ritual object that made winter feel real in October so that you actually prepared for it. We don't have Aya anymore, but we still have caterpillars. We still have birds flying low before storms. We still have ants building their little architectural masterpieces before the cold hits. The question isn't whether nature is still talking. The question is whether anyone is still listening. Next time you step outside and notice something odd, birds acting strange, your dog hiding under the bed for no reason, the air smelling different, don't dismiss it. You might be tapping into a system of knowledge so old and so sophisticated that we spent most of human history building it and only a few centuries forgetting it. Our ancestors didn't survive 20,000 years of winters because they were lucky. They survived because they paid attention. Maybe it's time we started doing the same.